Electric flux. Electric flux means electric lines of force passing normally through a surface. Here, electric lines of force passing through a surface is shown. The normal of the surface is A. The electric field line makes an angle theta to the direction of the electric field. The angle between the normal to the surface and the electric field is decreasing. Electric field lines are normal to the surface. The angle between the normal to the surface and the electric field line is 0. Let us see another surface through which electric field lines are passing. The normal to the surface is N. Here the normal makes an angle theta to the electric field lines. Angle between the normal to the surface and the electric field line is decreased. The surface is normal to the electric field lines. The normal of the surface and the electric field lines makes an angle 0. Therefore, electric flux can be defined as the electric lines of force passing normally through an area. The electric flux is represented by the letter d phi, and ds is the area of the surface. Here, the surface area is reduced to be unity. You already know d phi is the flux through area ds. If you consider the flux through unit area, that is represented by d phi by ds, that is E. Electric field can be defined as electric lines of force passing normally through unit area. It is also known as electric flux density. If E represents electric flux through unit area, then electric flux through an area ds is given by d phi is equal to E dot ds. The surface makes an angle theta to the electric field. So, the d phi can be written as d phi is equal to E dot ds, or d phi is equal to E ds cos theta. Now you know d phi is equal to E dot ds. If the surface is normal to the electric field lines, theta is equal to 0. d phi is equal to E ds cos 0, that is equal to E ds, or the flux is maximum. The surface is parallel to the electric field, that is, angle between the electric field and the surface is 90 degrees. From the equation, d phi is equal to E dot ds, theta is equal to 90, d phi is equal to E ds cos 90 is equal to 0. So the flux through this surface is 0. d phi is equal to 0. Electric flux through a cylindrical surface placed in a uniform electric field. Consider a cylinder which is placed in an electric field. Here, three surfaces are to be considered. The surface A and B, which are plane, and the surface C is a curved or cylindrical surface. Consider the area of the surface A and B as ds, and the area of the curved surface as S. The flux passing through the plane surface A and B are normal to the surface. Through the surface B it enters, and through the surface A it exits. Let us consider normal to the surfaces. Normal to A is N. The normal and the electric field lines are in the same direction. Normal to the curved surface, we have to consider it at a very point of this surface. Now let us consider this point. The normal of the curved surface and the electric field lines makes an angle 90. The normal to the surface B and the electric field lines makes an angle 180 degree. The normal is drawn from the surface to upward direction, and the electric field lines are enters the cylinder. So these two lines are in the opposite direction and it makes an angle 180 degree. The total flux through the cylinder is calculated by flux enters through B plus, flux exits through A plus, flux through curved surface. Flux enters through the surface B is equal to E dotted ds. Exit through the surface A is E dotted ds. Plus the total flux through the curved surface is represented by E dotted S. You already know. Here the angle is 180, so we can write E ds cos 180. Here the angle is 0, so we can write E ds cos 0. Here the angle is at every point we have to consider, and it is 90 degree, that is Es cos 90. That is equal to minus EDS plus EDS plus 0 is equal to 0. This means the total flux through a cylindrical surface which is placed in an uniform electric field is 0.